let's take a look at our first one here. And I was just wondering why my calculator went to La La Land there, but it came back. Get my pen to work here. There we go. Excuse me. We got y is equal to x to the third plus 5. And y is equal to x minus 1. And x is equal to negative 2, and x is equal to positive 2. And it says find the area of the region bounded by this. Well, let's graph this and get an idea what it looks like. I'm going to press my y equals. I got plot 1 on, you shouldn't, but I'm going to do an up arrow and do enter and plot 1, shut that off, down arrow. Okay. This is, and then I'll do zoom and then 6 for z standard. Okay. Now I should be at the same place you are. So I'll press y equals, and I'll do my x to the third. So I do x caret 3 plus 5. Then I'll down arrow, and I'll put in x minus 1. And then graph. Well, there's y1, and there's y2. Now, it tells us bounded by x equals negative 2 and x is equal to positive 2. So those are the vertical lines. The question is this point of intersection here? You know, what is that exactly? Well, we can use a calculator to find out real easy. If I do second trace and choose intersect, assuming that we'll put one of our functions on y1 and one of them on y2, all we do is do an inner on first curve, and we'll do inner again on second curve, and for our guess, we'll put in an x value close to where we think the answer is. Negative 1 maybe? So I'll type in negative 1 and push enter. Come back and tells us x equals negative 2. So that's good. That actually corresponds with this one right here. Now technically we didn't need that restriction then. We just needed x equals 2. Now if I wanted to find that intersection by hand, in case you're real curious, what you do is you set the two functions equal to each other. So I got x to the third plus 5 equals x minus 1. Get everything over one side, so I take the x over, becomes a negative x. Take the negative 1 over, it becomes a positive 1. And we got x to the third minus x plus 6 equals 0. Now this doesn't factor at all. So what we have to do is we have to use the fundamental theorem of algebra. If you remember right, this is P and this is Q. We list all the products down. That gives us P. Well, that'd be 1 times 6 and 2 times 3. So we'd have these. And then Q is the numbers before our x, the largest term, or leading term, which would be 1. And 1 times 1 gives you that. Now all of our possible answers would be each one of these P values over that Q value. 1 over 1, 2 over 1, 3 over 1, and 6 over 1, which would give us 1, 2, 3, and 6. Well, then what you do is you plug each one of those into synthetic division and see which one gives you 0. Well, remember synthetic division, we're missing a term, so we have to put a 0 there. So that's why we go from 1 to 0 to negative 1 to 6. So I add, multiply, add, multiply, add, multiply, add. And we're looking for a 0 here, which we don't have. So then we go to positive 1. So we've got 1, 0, negative 1, 6. And so we add, multiply, add, multiply, add, multiply. Did I do that right? Let's see. Add, multiply, add, multiply, add, multiply. Okay, add, multiply, add, multiply. It's been a long day. Add. Oh, that seems weird. Anyway, it came out 6. Well, my next one would be negative 2. So add, multiply, add, multiply, add, multiply, and we get a 0. We get a 0 here. That means it intersects at negative 2. And we could then set this equal to 0 and use a quadratic formula, but Anyway, we know it intersects at 2, or negative 2, sorry. So now we're ready to set this up. So our area is going to be from negative 2 to 2, and the graph above, which is the x to the third, plus 5, minus the graph that's below, which is the x minus 1, dx. So negative 2 to 2, x to the third plus 5. That negative switches those signs. That becomes a negative x plus 1. Which gives us negative 2 to 2 of x to the third minus x plus 6. That's no surprise. That's what we just came up with over there, right? Okay, so now we're going to find the integral of that. We'll add 1 to our power, divide by our new power. So that gives us 1/4 x to the fourth. Minus, add 1 to our power, divide by our new power. So minus 1/2 x squared. And the 6 becomes 6x. Well, now we're ready to plug those in. So I got 1/4 times 2 to the fourth minus 1/2 times 2 squared plus 6 times 2 minus 1/4 times negative 2 to the fourth minus 1/2 negative 2 squared plus 6 times negative 2. Well, 2 to the fourth is 16. 16 divided by 4 is 4. Minus 2 squared is 4. 4 divided by 2 is 2. Plus 12 minus negative 2 to the fourth gives us a positive 16. Divided by 4 is 4. Negative 2 squared is a positive 4. Divided by 2 is 2. So that's a minus 2. And 6 times negative 2 is negative 12. So this gives us, let's see, 214 minus 4 minus 2 is 2. That's negative 10. 14 plus 10, which gives us 24. Now, I like to do things by hand, but at the point where you get set up right here, if you want to use the calculator, if it gives you an exact answer, I'm happy with that. So if I come over to my calculator, let me clear out y1 and y2. So on y1, I'm going to put in x to the third. So x carried 3 minus x plus 6. And then we'll do second trace. And we want to choose the integral, the seventh one. It'll come up and ask us for our lower limit. So we'll put in negative 2, enter. Come up and ask us for our upper limit. So we'll put in a positive 2, enter. And you see we come up with 24. So I don't care how you do it. If you want to do that, get that. As long as it's an exact answer, then we're fine. And that's the end of that problem.